let's start with our next problem. Implement data standardization based on Sklearn. Okay. Okay, so we have the code already provided, the template provided. We have to write the code over here. We have to fit the data. This is the initialization. In this function, you need to initialize the standardization function. Okay, so it has been imported from the preprocessing plane. This is the std data. Okay, let's go this first. So in this function, we need the initiation of the standard scalar from Sklearn. Okay, so let's instantiate it. Okay, set dot scalar equal to standard scalar. Okay, in this function for data, we need to fit the data into a model. The data type of the data is integer. Okay, so here we have to fit the data set dot scalar dot fit, which is the data, and like the returning is none. Okay, and here we have to return the transform data. Okay. Set dot scalar dot transform data. And we have to return it. Let's see. So memory limited data, we need to standardize the data into the model. After putting data after standardization need to be returned in the function. The data type of the data is in the array. The returning data type should also be in the array. Okay. So why was there though? Okay. Let me prove its standardization tool is already here. So the question and compare answer return the following data sets. So let's test it on. Okay. And what is output? Memory limit exceeded. Okay. Alright. Okay. Transform data. We have to print the data and check it. Then return the transform data. Let's try to run it and see what's output. Now it is accepted. Okay. Let's submit it then. We have to implement data normalization based on the Sklearn. Okay, we have already been imported min-max scalar. And now in this function, you need to initialize a normalization function. Okay, so self.scalar or normalizer. Min-max scalar. In this function, you need to fit the data to the normalization function. Okay, it's similar to the previous questions. Just here, the min-max scalar is being used instead of standard scalar. So normalizer dot fit on the data which is provided as an input. In this function, you need to transform the data. Okay, transform data equals the normalizer dot transform the data, return the transform data. Let's test it. It should be working. Let's move on to our next question. It says calculate accuracy score based on Sklearn. So we have provided this as a template code. We have already imported the accuracy score function from the Sklearn.metrics class, and now we have to calculate the accuracy. So return the F1 score for the given true label and the predicted label. Okay. So in this function, you need to calculate the F1 score using the given true label and the predicted label. Okay, given true label, which format is in the array. Okay, in this function, we need to complete the accuracy, in which we need to calculate the F1 score using the true label. Okay. So yeah, or we can say score equals to accuracy score. Both are in the array, so we don't have to transform anything. By predictions, by true, return score. Okay, there it says F1 score, but okay, it worked. It says text classification based on the plain Bayesian algorithm. Okay, so we have been provided with the explain byte. We are using multinomial naive. Okay, so let's initialize a model logistic regression classifier. It should be multinomial naive. Okay, let's initialize it. Self.model equals multinomial naive. Okay. Now we have to fit the data, fit the model on the data. Extreme, so it should fit here. And now we have to predict the input on text data. Okay, self dot, or you can say it as wireframe. This should be the model which takes the input of text and makes a prediction on it. We have to specify here predict, and this should return wireframes. Let's test it. Yeah, it works. let's move on to our next question, which is calculate precision score of data based on Sklearn. So we have imported the precision score from Sklearn.metrics. This is the precision function. So okay, so we just have to return, or we can create a variable where we will return the precision score between the true label and the prediction label. And then we have to return the score. Okay, let's test it. Okay, it works. Let's move on to the next question, data analysis for mean value. So we have been given a table. Okay, calculate the average of the IMDb user ratings for some movies given by IMDb. Okay, so this is just a Pandas based solution. We have to calculate the average. We have been given the data and we have to return the float, and which we have to calculate the average for given by IMDb Internet movie database. Okay, IMDb user ratings. Okay, so we have to return, or we can just say it as mean value or average value equals data IMDb column. We select the mean and return the average. Yeah, this works. Let's move on to our next question, which says logistic regression doing dichotomous classification for cancer bridge. Okay, so this is just a logistic regression based classification. Okay, so if in this function you need to initialize the logistic regression, it has already been imported from linear model class. Self.model equals to logistic regression, and here we have to fit the data. Okay, so what we can do, self.model.fit on x train and y train, and we have to predict. Okay, so self.model.predict on x's and return it as y predictions. Then the function should return the y predictions. Let's test it. Okay, it works. So let's start with our next problem. Intercept even numbers for given sequence. Okay, so you need to define the code solution.py so that the array slice function can extract even numbers from the sequential order array, starting from 0 into the new array using the Numpy array slicing operation. Okay. So let's just print the array to see how it is. Like what are the test cases? Okay, so it is basically, so we have to take the even numbers only array where the condition is array modulus of true equals to 0. This should be returned. Let's see if this works. Yeah, it works. Let's move on to our next problem, plotting lines based on map.lib. Okay, so we have the problem where we have to code the function to plot the line through the points 1, 2, 2, 4, and 3, 6. Okay, we have been given the x coordinates, the y coordinates. We just have to simply state the figure, which is clearly.figure dot I guess we size to be already taken as by default, I guess. Okay, it is already been set. Okay, so we don't have to do this, or we just have to plot the line, clearly plot x and y, and it will be run it. Yeah, it works. It isn't displaying over here, but it works as it is accepted. Let's start with the next problem, compute binary cross entropy with log loss. Okay, so we have already imported the log loss from Sklearn.metrics, and for the binary cross entropy, we have been given true label and protected label as the inputs. So what we can do, we have to, so let's say this is the loss, we have to get the log loss from true labels and the predicted label, and return loss. Yeah, it works. Yeah, so in the next problem, we have to create a Numpy array. The function create array is defined in the solution. To create and return a Numpy array of size 2 cross 3, you need to create an array which fit the requirement. Okay, so we can create an array, required array, or simply array, and we dot array, and we have to create it for 2 cross 3. So 1, 2, 3, 4, 5, 6. This is the 2 cross 3 array and return an array. Okay, that should work. Yeah, it works. But let's say if we implement it using different values, and it should be 2 cross 3, and if this is the okay, the limits of the array you created do not match the requirements. Okay, we have to create it using by specifying the numbers, elements, everything, and so on. And it is accepted. So in our next problem, we have to implement dimensionally ref reduction based on Sklearn. Okay, so we have already imported PCA from the Sklearn.decomposition, and this is the template function. In this function, you need to initialize again and classify, or basically PCA. They haven't updated the comments. So PCA, we can say dimensionality reducer. This is PCA. Okay. This PCA takes an argument without being specified. Okay, let's try it with z.fit on z.dr.fit on input data and return z.what reduce data is z.dimensionality reducer dot transform the input data and return. Okay, let's try it. Oh, okay. This is a function. We don't have to specify it because this isn't a class. But let's see if this works or not. Yeah, it accepts. Yeah. So in the next problem, data frame, data type creation. Okay. So return a data frame, create series. Okay, this data frame. Okay. So please define the code to implement the create data frame function to construct a data frame data type with the following requirements. The index of the data frame type is constructed data frame. Okay. Create of data frame we will create it using string A and then B and C. These are the indexes. Okay, columns. Oh, okay, sorry. So this should be, I think this is the header's name and each. I don't require this. Name should be Tom, Jack, and Frank. And ages 1, 2, 3. They are arbitrary numbers because we are free to choose any numbers. And this should be required data frame. Yep, it is accepted. So now we have series data type creation. Okay. So here we have to create a series instead of data frame which we have created in the last problem. So we can say series with index name, index as A, B, C, and D. And the name of the constructed series type is Python. Name. Okay, and the values of the constructed series type is not required. I think we will read. Okay. I will return the answer. This is work. Okay, and we have to label it also. This should be in, or we can say as name. Why does this doesn't work? Okay, is it on? Argument, let's see. Yeah, okay, name, okay, this one. Yeah, it works now. Let's start with the next problem, which says one hot encode. So basically one hot encoding which we have to do. So we have already imported it from the Sklearn processing class. In this function, you need to initialize one hot encoder. So self.encoder equals one hot encoder. And now we have to fit and transform the data. So transform data is self.encoder dot fit transform, and that will be the data and return the transform data. But this doesn't work. That is not okay. This is internal error, I guess. It should have incorrect answer. Okay, what was the problem? Problem was in so there it says the function doesn't require data entry. What does it mean? Okay, so it is transforming the same data. But if we do it in the same fashion, it should work like this. Because other than that, the code is similar. So what's an issue? It's false. So why is that this works. Okay, sparse is what we require. So our next question is implement k-means clustering algorithm based on Sklearn. Okay, so we have k-means. So we will create a model, clustering model, where we will initialize the k-means clustering into 3 classes. I don't know whether it is clusters or number of clusters or classes. Let's just simply say it has 3 for now, and then model dot fit on the data, which is the input data, and then return the data. Model dot predict input data. Let's see if this works. It works. Calculate R2 score or model based on Sklearn. Okay, so we have to calculate the R2 score. It is similar to how we calculate accuracy score and basically the logs and all. So basically the score is R2 underscore score calculated for true value and predicted value and returned as score. Yeah. So we have to describe and get the data, basically return as data frame the described value, which will be data dot described and return it. Yeah, it is accepted.